Just a stone's throw away from the Tucson airport is a collective of greenhouses and buildings that house the University of Arizona's Environmental Research Laboratory. The laboratory represents a collaborative enterprise between several UA departments and centers, all with a focus on water usage and best practices.
And so these guys here are working on these problems where they look at how the contaminants actually travel through the pipes and how they travel when they actually get to a junction and how they mix. You know, and it depends a lot. Here you can see
the cleaner you keep a city's water supply, the less of it you have to use. So better anticipating how potential contaminations flow through a city water grid is essential.
So this is the cross-junction animation here. So what we're seeing here is a simulated contamination event in water pipe networks. So we have a contamination event. This could be E. coli or chlorine or some chemical or some other organism that's injected in here coming up from the south. And the question here is, what happens here? Does it completely mix, and do you have 50% go this way and 50% go this way? Or does it depend on the flow and the pipe diameter and pressure and all of those other issues? So this is a model city grid here. This whole laboratory is a model city grid. On the micro scale, you have these junctions here, and you have the ability to take water out at any point and compare it to your mathematical model.
Besides testing the water grid, the ERL also has a facility for testing and calibrating commercial water sensors to ensure that they are working as efficiently as possible.
So this is the real-time water sensor facility. What happens in here is we have a suite of sensors, water quality sensors, and we can detect what's going through the water system, microbes and chemicals. We can use these carboys here and set these up at different contaminant concentrations. So we can have E. coli at 100 per milliliter, E. coli at 1,000 per milliliter, E. coli at 10,000 per milliliter, and at 100,000 per milliliter. And then what we'll do with a typical experiment is we'll pump in the high concentration one and see what happens with the sensors, and then we'll slowly scale it down as we go out throughout our experiment. The idea is that detecting microbes is very expensive and time consuming, and so we're trying to find faster ways to approximate microbial contaminants and chemical contaminants.